All right, guys, so this is lesson 6-4, okay? Logs and exponential are a big part of this class. We're going to be doing them for a while. So inside this box right here is how to convert, okay? So right up above that, let's write down the word convert. If you don't know how to convert from a log to an exponential, it's going to cause a lot of problems. So we've got to be really, really good at this, okay? Okay, so everybody look forward and kind of stick with me right here, okay? So the way that you read this right here, guys, look, it's log base b of x equals y, okay? So this is the base right here. The b is the base, okay? If you had 2 to the third equals 8, the base is the 2, okay? So the base over here in the log is also the base over here in the exponential. So here's how you rewrite it. Guys, look. You take the base and you write it down, the b. You raise it to the other side, which is a y, is equal to, the only thing I haven't written down is an x. And then going from exponential to log, you write, see that b, it's the base, so it's the base over here. So log base b of the other side is an x is equal to y. Okay, so let's do a few. This is absolutely essential that you know how to do this, okay? So that's given in log, and we want to write it in exponential. So see that little number, that 5, you start right there. So everybody write down the 5. Then you raise it to the other side. On the other side, we have a 2, and that's equal to, what's the only thing I haven't written yet? An x. Please don't write x equals 25. If you write x equals 25, you're going to miss it because it's not in exponential form. There's not an exponent anymore, okay? Okay, this one right here, write down the little number, 4. Raise it to the other side, which is a 3, is equal to 64. Okay, do the next one. Write down your 5. Now you're going to start talking to me, okay? You raise it to the, can you tell me? The second, the other side, is equal to, what's the only thing I haven't written? 25. Okay, everybody in the room's talking to me. Tell me what to write down first. 7. Raise to the, talk to me, 0 is equal to 1. Very simple, okay? Hey, Brevin, I have you marked absent right now. Will you remind me when I'm done to change that to late, okay, bud? Speaking of that, check your citizenship for my class. Some of you have absences that are not excused. Some of you have truancies. And some of you have tons of tardies. If you have any of those scenarios, you're going to have a U. And I emailed your parents and you yesterday if that's your situation, okay? Okay, let's do question 2. Write each equation in log form, okay? So everybody write down the word log. Do you see in the original problem how the base is the 6? So the base is the 6 here. You guys, it's subscript, it's below the log, and it's smaller, okay? And it's of the other side, which is a 1, is equal to, the only thing that I haven't written is a 0. Okay, let's do the next one. This is log base. What's the base up above the 5? So that's the base down here of the other side, which is a 25, is equal to 2. Okay, next one. This is log base. Everybody tell me what to write. 4 of, keep talking to me, everybody, 16 is equal to x. Now, I want you to look forward. Everybody in the room right here, I want you to look forward. So I'm picky about this, okay? Look forward. If you're not looking forward, then it's going to be you that misses it because you're not listening, okay? Okay, look right here. This is wrong. Do you see the difference? Okay, the 16 is not an exponent. The 16 is on the same level as the log. Okay, so the 4 is subscript. Then what some people do is things like this. They start like going all twisty. And then I'm like, you know, I kind of wrote that too good probably. But anyway, they start going all twisty. And it's like, what's that? Is the 16 an exponent? Is it? So just be really careful and really clear, okay? Okay, this one right here. This is log base. Everybody in the room, talk to me. 3 of, talk to me. 1 over 81 is equal to -4. Good, easy. Now, one thing that I do, look forward for just a second, if what I'm taking the log of starts getting complicated, I throw parentheses around it, okay? Do you have to? Nope. Do I think it's a good idea? Yep, because it keeps everything clear, okay? So that's my advice. Okay, now they want us to evaluate these. So what I would like you to do is set all of these equal to x. Okay, set these equal to x. Let's do the next one. And I want you to write this down. I'm going to ask you this 1,000 times, and you're going to get annoyed. But besides getting annoyed, you're also going to do it right, because I'm going to ask you so many times. When you get stuck, you convert. Okay, I want you to write that down. Okay. See the log and the 2 and the 8? Everybody freeze for a second. Do you see all those things? They're all stuck together. They're all one thing. Just like right here, if you had 3x minus 2 equals 7, don't write that down. The 3x and the -2, they're stuck together. I couldn't like add 2 or something. It's all one thing, okay? I can't like divide by 2 or divide by 8. None of those things make sense. So I'm stuck. So when you're stuck, you convert it. Everybody write 2 to the x power is equal to 8. And then I want you to write the word think. I want you to just think about it. 2 to what power is 8? Everybody tell me. X equals 3. Sure. X equals 3 and you're done. Okay, let's do this one. Yes?
Isn't there another way to solve for that?
There are so many different ways to do these. Tons and tons and tons. So, any way is acceptable as long as I can understand. I will always teach you the method I think you're going to be the best at.
So if you did like log 2 to the 2 to the 3rd?
Yes, and pulled it down in front, and you got a 3, exactly the same thing. I don't think we've discussed that yet, and so I don't want to get ahead of myself, but yay, okay? Okay, let's do this one, let's convert it. We're stuck. Everybody write 5 to the other side, which is an x, is equal to 1. Then I want you to think about it, okay? 5 to what power is 1? Everybody tell me. 5 to the 0. So you've got x equals 0, and you're done. Let's do the next one. Let's convert it. This one's a little trickier, so watch. 7 to the x is 1 over 49. Okay, so it's kind of weird now. I do notice that 49 is a power of 7. Okay, so everybody write this as 7 to the x is 1 over 7 squared. 7 squared is 49, right? Now I'm going to take that 7 squared and I'm going to pull it up to the top. So 7 to the x power is 7 to the, let's think about that. If it's 7 squared on the bottom and I pull it up, what do I get? -2. Yeah. So if 7 to the x is 7 to the -2nd, then I know x must be a -2, and I'm done. Okay, who says I'm totally good? I get this, I feel good. Okay, good. All right, right here. Let's convert it. Okay, so this is 8 to the x is equal to the square root of 8. Okay, well, I've got my 8's matching. The square root's kind of weird. So 8 to the x is equal to 8 to the, guys, what's another way to write the square root of 8? 8 to the 1/2. Good. Then if 8 to the x is 8 to the 1/2, then x must be 1/2. That's your answer, and you're done. Okay? All right. Grab your calculator, please. Don't start punching things in. Stick right tight with me, okay? You guys, look at that log on question A. There's no base. If there's no number written right here, then what is the base? 10. Everybody just fill in a 10, okay? Look at your calculator. You have a log button, but there's no base with my log. What's the base on the calculator, guys? That's base 10. So everybody just hit log 100, close it off, hit enter, and that is a 2. Easy. Do the next one. ln. ln is weird. I missed one lesson. Did we talk about ln yet? We did not. Okay, everybody write down underneath it, This ln is the exact same thing as log base, talk to me, e of 1.43. Now, do you have to put it in your calculator as log base e? No. But I just want you to know that's what it is. You also have an ln button on your calculator. Everybody hit ln 1.43, hit enter, and I want you to put right here 4 digits. So the directions are telling you to round to 4 digits. So it's 0.3577. Okay, next one. Don't grab your calculator on question C yet. Can anybody say anything to me about question C before we even do it? It's not going to work out. How do you know it's not going to work out? Because it's a negative. What if it was a 0? Can you take the log of 0? If you forget, what can you do? Stick it in your calculator, right? If you go log 0, you get an error. So it can't be 0 and it can't be negative. So this right here is not possible, is how we're going to say that. Okay? Grab your calculator and let's just show that. Everybody hit ln, negative 2.64, hit enter, we get an error, we realize, oh yeah, it's not possible. Okay? All right, question E. Okay? Up above that, I want you to write the word stuck. It is super important that you understand what stuck means. Okay? You've got your log, you've got your base 10, and you've got your x. Everybody look right here. Some people think you can divide by x, right there. No, the x is part of the log. Some people think that you can divide by 10. You can't do that. That's like saying the square root of x minus 3 equals 4, means you can add 1 to both sides and you get the square root of x equals 5. Everybody knows you can't do that. It's the same thing with logs, okay? So we're stuck. Everybody in the room tell me, when you get stuck, what do? You convert it. So this is base 10, right? So everybody go 10 raised to the 0.7482 is equal to x. Okay, now grab your calculator. Everybody go 10 to the 0.7482, hit enter. 4 digits would be 5.6002, and I'm done. Okay, the next one. Everybody in the room tell me, am I stuck? Yes or no?
Yeah.
Yes, I am. This ln is log base e of x. I want you to write it like that. The reason I'm stuck is because there's nothing in front of the log that's multiplied, there's nothing behind it that's added or subtracted, so I convert it. So it's e to the 1.335 is equal to x. Grab your calculator. The e is second ln, so look what you do. Hit second ln, 1.335, close it off, hit enter, and you get x equals, now this is weird, look, 3.79999. So here's my 4th digit. The 9 tells you to go up. So the 7,999 goes to what, everybody? 8,000, right? But you guys know all those zeros aren't necessary, so we're just going to say 3.8. You can write the zeros. They're not necessary, so I never write them. Okay? Okay, that's it. Who says I'm good so far? I feel great about this. Okay, good. Now we're going to graph logs. Okay, I want everybody to freeze for a second. You know how we started with the parent graph, like y equals x squared? And then we would shift it right or left or up or down or reflect it or stretch it. That's what we're going to do with logs. Okay? I'm going to teach you how to graph a log. You're going to get so good at it. I'm not exaggerating, and it's not a race. You're going to be able to graph that log in 15 seconds. You're going to go boom, 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 done. Like that easy, that quick. You just have to remember, like 3 things is what you have to remember, okay? First of all, take this y equals log base b of x, and right underneath it, I want you to write that that is a parent graph. There is no adjustment to it at all, okay? Here is the graph of a parent log, okay? Grab your pencil and just dash that in really clearly. Make sure that you understand that's an asymptote. You guys, if your asymptote is on an axis, people get all nervous. Oh, it's on the axis, you know, I'm going to pull it off to the side. No, it's right on the axis. You just extend it beyond the axis. That's all you do, okay? Here's what you have to remember, okay? Three things. You have to remember x equals 0 is your asymptote. Always. You have to remember that this point right here is always there. This point 1, 0 is always there. The third thing you would need to remember, guys, if this is log base b of x, then your third thing you have to remember is that you have the ordered pair b, 1. That's all you have to remember. Okay, so if you look at this graph, right, this particular graph, I didn't give you the equation of that graph. We could figure it out. Look, here we are at the origin. I went right 2 and then up 1. I know my base has to be 2. So the equation for that graph is y equals log base 2 of x. Why? Because I went right 2 and then up 1. Whatever I go right before up 1 is my base. Who says I understand what you said? Okay, great. Look at the graph. Everybody in the room tell me the domain. Domain starts at the left, goes to the right. It starts at a 0. Does it actually hit a 0? Talk to me about that. No. This is so crazy. Look what I had on the midterm. I'm like, oh my gosh, why would you do this? Like, you're making me crazy. Look, I'm not exaggerating. What do I do with that? Take off 4 points? Take off 4% off your midterm because you didn't use your eraser? Please, I'm begging you, use your eraser, okay? So I don't know what that is. If it was my test or quiz, I'd mark it wrong as fast as I could. No way. I don't know what that is. So please, please, please be so careful, okay? Tell me how to close my 0. Is it with a parenthesis or with a bracket? Which one is it? It's a parenthesis because it never touches the next value of 0. And then how far does it go? Forever. Okay? Range is y, start low, move up, it touches every single y. So the range is everything. Okay? X-intercept, right here, that's that dot I gave you. It is 1, 0. The asymptote is the red dashed line. Look how easy it is to tell. What axis did that cross? It crossed the x-axis. Where does it cross it? 0. Okay? Okay. Do me a favor and just look up for a sec. Just relax for a sec. Let me show you a few things, okay? Okay, look at this right here. Y equals log base 7 of x. Is that a parent? Tell me yes or no. Is that a parent graph? Yes, it is. Okay? It's okay that it's a 7. Look at this. Is that a parent graph? No, because you have an adjustment. Is this a parent graph right there? Yes or no? No, because you have an adjustment. Is this a parent graph right here? Sorry. Is that a parent graph? No, because you have an adjustment. So in order for it to be parent, it has to be y equals log base b of x, okay, something like that, okay, with just some number sticking in there. Okay, let's go ahead right here. So we already talked about this right here, that if it just says log x, that's log base 10 of x. If it says ln of x, then that's log base e of x, okay? Okay, let's go ahead and graph number 5. Everybody sit up, pay attention, okay? Here we go. It's not a race. I can graph it in 10 seconds. Okay, look. It's a parent. I have an asymptote right there. Dash in that asymptote. Since it's a parent, I know that it hits the point 1, 0. My base is a 2. I know that from the origin, if I go right 2, I go up 1, I graph it in, there's my graph. That easy. 3 things, asymptote, 1, 0, and b, 1. That's all I have to remember, okay? Now, they're asking me to fill in a table, okay? That's fine. Do I think Weber's going to make you do a table? No. But what if they do? I'm not going to make you do a table, I'm telling you that right now. Because the table is to help you graph it. But I just graphed it, and I didn't do anything with the table. So the table's, in my opinion, unnecessary. Okay? Okay, everybody write down y equals log base 2 of x. Now, You could choose some values of x and find the y, but it's kind of awkward because it's in log form. So I'm going to convert it. So I'm going to go 2 to the y is equal to x. Now I'm going to plug in a value of y and give me the value of x. For example, if y is a 0, 2 to the 0 is a 1. If y is a 1, 2 to the first is a 2. If y is a 2, 2 to the second is a negative 4. Positive 4, pardon me. What is 2 to the negative first? Can anybody tell me that? It is 1/2. Now if you look at these points, look guys, go right 1/2, down 1, it's on there. 1, 0 is there, 2, 1 is there, 4, 2 is there. Make sure 4, 2 is on your graph. Okay? Okay, next one. Everybody write down y equals log base e of x. Dash in the line. That's the asymptote. It always hits the point 1, 0 if it's apparent. What's my base on this, everybody? E. And what is E equal to? E is approximately 2.71, I believe. Right? You guys are saying 2.1. Yeah, 2.71. 828, blah, blah, blah. It's 2.7. It's just like pi. It's just a number. It goes on forever. It's constant. It's always the same. So on this graph, how far do I, you guys, some people do this. Look, they go right from the initial dot. No, you go from the origin. So put your pencil on the origin. Then go 2.7, up 1, curving in, go steep like that. Done. Okay, let's fill in this table. Convert this. E to the y is equal to x. What if y is a 0? E to the 0 is a 1. What if y is a 1? E to the first is an e. What if y is a negative 1? What is e to the negative first? How could we say that? 1 over e. And that's good enough for me, because I'm not even going to use the table to graph it anyway. I did the table after the graph. Okay? All right. Here's what it's going to look like. Here's this graph. They want you to say the domain and the intercepts and the asymptotes, and they want you to graph it. Okay? So I want you to go like this. Go like this and write the word skip. You're going to skip those. You're going to graph it, and then you're going to go back and answer all those questions. Okay? Now, I should have edited this when I edited your workbook at, in December or whatever. Weber State used to make us do 3 graphs. Okay? Here and here and here. So what I would recommend you do is I would graph the parent, and then I would make my adjustments. Okay, that's me. Okay, so I want everybody to write down y equals log base 3 of x. If I were you, I would take the 10 seconds it takes to graph my parent. Okay, so dash that asymptote. It hits 1, 0. Put my pencil at the origin. I go right 3 and up 1. Why 3? Because my base is a 3. Okay, now I'm graphing this. Look, f of x equals log base 3 of x minus 1 minus 2. Some person in this room, tell me what the negative 2 is going to do to my graph. Can you tell me? Moves it down 2. If it's outside of the log, do you see how it's not in the parentheses? It's outside. It's up or down. Just like this, guys, look. If you had f of x equals x squared minus 2, that's a down 2. Same thing here. Somebody talk to me about the plus 1. What does that do? Moves it right 1. It's the opposite of what you think. Yep, right 1. Okay. I always do the asymptote first. Always do the asymptote first. If you miss an asymptote, you're going to miss you miss points on every graph. Okay? You've got that asymptote. Look right here for 2 seconds. Here's my asymptote. I shift my whole graph down 2. Did I just change my asymptote? No. Okay? But right 1 does change it. So here's my asymptote right there. Dash that in. Always start with the asymptote. Put your pencil on 1, 0 on the new graph. Now move your point down 2, right 1. There you go. Everybody go to 3, 1 on the new graph. Go down 2 and right 1. There it is. curve it in, and you got it. Who says easy? Give me feedback, how we're feeling. Okay, good. Now, look at the domain. You guys, it's 1,000 times easier to find the domain from the graph, I think, in my opinion. Look at the final graph. None of the negatives hit it. It doesn't hit it until we get to a 1. A 1 actually does not hit it. So it's 1 with a parenthesis, and that is 2 forever. Find all the intercepts. Some of you guys mess this up on quiz 2. You've got to go x-intercept, give me a list, y-intercept, give me a list. I expect you to differentiate those, okay? Now, little tricky, okay? Y-intercept, none. The x-intercept, I didn't quite get that far on my graph, okay? I know that the x-intercept is a y value of 0, okay? So, let's let y be a 0 on this graph, okay? So everybody go, you know what I'm going to do? Can I see, Miranda, can I see your notes from last time? I just feel a little bit out of sync about what you guys have learned. Okay, so we are going to draw an arrow right here, and I want you to write the word postpone. We are going to postpone finding the x-intercept, because in order to find the x-intercept, we have to go through graphing logs, which is coming up. So I promise we'll do it, but I feel like if I do, I'm in a confusion, we're getting ahead of ourselves, okay? So, yes, I believe on the homework I wrote on there, if you look through this. Yeah, if it asks you for x-intercepts and you have a complicated log graph and it's unclear on your graph, then don't worry about it. If it's pretty simple, then you're good. Okay, look at the dashed line. The dashed line crosses the x-axis. Where does it cross it? X equals 1, and we're done. Okay? Okay, example 7. You guys, example 7 looks really bad. Someone tell me what looks bad about this graph. Okay, so it's complicated, right? But it looks like ugly. There's something I could do to make it look better. Put the 4 on the right side, on the other side, yes. So everybody go, y equals negative ln of x minus 1, plus 4, like that, okay? A, B, and C go like this, and I'm going to skip those. First thing I'm going to do is graph it, okay? If you can go straight to the graph on this, go for it, okay? My advice to you is do not do that. That's my advice, okay? Okay, so right there on D, I want everybody to write y equals ln x. And I want you to write y equals log base e of x. I'm going to graph the parent. Do you have to graph the parent? Nope, it's your decision. I think it's crazy if you don't. That's just how my brain works, okay? Here's the parent, 1, 0, right, 2.7, up 1, there's your parent graph, okay? The next toughest thing in this, you guys, is the negative. Somebody tell me what that negative does to my graph. Can you tell me? Reflects it across the x, yes. So right here, I'm going to say reflect across the x-axis. So I'm going to dash it. The 1, 0 is not going to change. The 2.71 becomes 2.7 comma negative 1, and now my graph looks like that. The next two transformations, I feel pretty good about doing those at the same time. So the plus 4, everybody in the room tell me what the plus 4 does to my graph. Up 4, okay? And then everybody tell me what the minus 1 does. Tell me. Come on, guys. Right 1. Okay? What do I want you to put on that final graph first all the time? Tell me what it is. The asymptote. Okay? Does moving a vertical asymptote up 4 change it? No. But the right 1 changes it. So there's my asymptote. If you don't put the asymptote, you are going to miss a lot of points. Okay? Now, put your pencil on 1, 0. I want you to go up 4, 1, 2, 3, 4, right 1. Go to the point 2.7, negative 1. Go up 4, 1, 2, 3, 4, right 1. It's right there. Has the same look as the one before. There's my graph. My advice is draw the parent, make the reflection, and then do the other changes. Okay? Okay, now let's go back. Find the domain. I'm looking at the final graph. Domain is x, start to the left, move to the right. It's going to be 1 to infinity. The 1's closed with a parenthesis, and it's clearly a parenthesis because it doesn't hit a 1. Okay? Find all the intercepts. Everybody write x-intercept, y-intercept. I can tell that the y-intercept is going to be none. You'll be expected, like on your homework, to write that down. Okay? To find the x-intercept, it's going to be complicated, so I'm just going to say postpone. I promise. I think most of you would be fine if I did it. I just don't want to freak you out. It's coming up, I think, in the next lesson. Find the asymptote. That asymptote hits the x-axis. Where does it hit it? X equals 1. Done. Okay? All right. Who says I'm good? Raise your hand. Okay. Piecewise function. There was a piecewise function on your midterm, right? So surprised. Well, it wasn't horrible, but it wasn't great. I was super surprised. I thought, oh, they're going to get this. Well, it wasn't on any of the reviews, right? None of the practice tests. But you were supposed to go through your workbook for all those hours, right? So if you did go through your workbook for all those hours, I'm surprised if you missed it. You know what I mean? I think the people who missed it probably did not spend the time on their workbook, but I don't know. I don't know for sure. Anyway, let's go through this. Make sure we know how to do it piecewise, okay? Everybody write y equals log base e of x. It's the same thing as ln, okay? Yeah. So it's a parent, so it's going to have a dashed line right there. It's going to hit 1, 0. You go right 2.7, up 1, dash it in. Looks like that. Okay. The only part of that graph that's supposed to be there is smaller than 1. Okay. So anything bigger than 1, I have to get rid of. So the part that's going to stay is right there. Okay. And if x equals 1, it is on that graph, so my circle should be closed. Okay. Look at the next one. Okay. I am going to take 2 seconds, and I'm going to redraw the parent graph right here so everybody can see my reflection. So there's the parent. That right there tells you to reflect it across the x-axis. Okay, so the asymptote is still going to be the same. I'm going to graph it in green. The 1, 0 is still the same. The 2.71 becomes 2.7 comma negative 1, and it goes like that. Everybody draw this in. Okay, but the only part of the green graph that's supposed to be there are x values that are bigger than 1. Okay, so anything between 0 and 1, I need to get rid of, and it looks like that. Now I've got a closed circle intersecting with an open. Do you remember what that's supposed to be? Closed. Good. There's your graph. Okay, there's your graph. Let's just move on. Okay, find the domain. Okay, can you take the log of 0? Do you remember? Can you take the log of 0? No. Can you? What else can't you take the log of? Negative. So this 4x minus 5 must be what? Must be positive, right? So everybody go 4x minus 5. How do you say must be positive? How do you say that? Greater than 0. Yeah. So you go 4x is greater than 5, x is greater than 5/4. If they don't tell you how to write it, that's completely acceptable. Okay? Okay. This, write a note to yourself and say this is typical. That is how the problem is usually going to look. Question 10 is more complicated, but I still want to discuss it in case it comes up. Do you guys know what I was talking about on the midterm when I said it's twisty? There's twists on there. Who says, I understand what you were saying to me now? Yeah. Like you get the rational function and the top won't factor to find the x-intercepts. Well, we've never seen that before. You know what I mean? Stuff like that. Anyway, here we go. Find the domain of a log. Well, what you're taking the log of, which is right here, must be greater than 0. So everybody go x minus 1 over x to the second plus 4x must be greater than 0. Freeze right there and look at that. Okay? What am I supposed to do now? Can anybody talk to me about this problem? Say it again. Why would you do that? You're right, Abigail. She said factor the bottom. Why would you do that? That's good. Say it. Type 2. This is now critical numbers type 2. So the next step, Abigail is right, factor the bottom. So I've got a 0, I've got a common denominator, so the next step is to factor, and the bottom's the only thing that's not factored, so it looks like that. So then my critical numbers are x equals 1, 0, and -4. Do I have to worry about restrictions on this problem? No, why not? Because there's no equal sign. Good. Draw your line. -4, far away is a 0, right up against it is a 1. Circles are open circles. Nothing is squared or fourth or sixth, no even powers. So I know my signs will alternate, okay? Let's do a -5. Everybody go -5, store, enter. I like to put it right here. I think it's the safest place for you. If you put it there, you have to add parentheses there and there. So I'm going to go parentheses, membar, enter, -1, close it, divided by parentheses, membar, enter, x squared, plus 4, membar, enter, close it, enter, and I get a negative. I know it's going to go negative, positive, negative, positive. Okay? Greater than means positive. So I would shade here and here. In interval form, my answer is -4 with a parenthesis to 0 with a parenthesis, union 1 to infinity, everything's parentheses. There's my answer. Please don't think that the domain on log will always be critical numbers. That is rare. It's most always going to look like 9, and I do think you'll see something like 9 a lot. Okay? All right, here we go solving logs. Okay? Write down this, stuck, arrow, convert. Okay? Sit back for a second and look. Just kick back and look. You have got to understand the difference between stuck and not stuck. Okay? Everybody look at that. Is it stuck or not stuck? Talk to me. Stuck. You've got your log. The 3 is part of the log. The 2x minus 1 is part of the log. Look right here. Stuck or not stuck? Not stuck. What would you do to get the log along? Divide by 2. Look at this one. You have got to understand this. Please pay attention. Look at this. Stuck or not stuck? Not stuck. Why not? This guy right here. Okay. The 3 is part of the log. The 2 and the x and the 1 are all part of the log. This is one thing right there. Your brain should see y plus 2 equals 2. Because all that log stuff is stuck together. When you look at this, your brain sees 2y equals 2. Have you solved for y? No. Who says, I understand stuck and not stuck? Let me see. It's crucial. Yes. Sure. How about this? Stuck or not stuck? Not stuck. So you'd have to multiply by 4. Is that your question?
Yeah.
Okay, great. Okay, let's come back to A. Now, everybody in the room better know the answer to this question. Are we stuck? Yes, we are. The 3 and the 4 and the x and the 7 are all part of the log. You do not divide by 3. You do not divide by 4. You do not add 7. You convert it. So you go 3 to the other side, which is a 2, is equal to 4x minus 7. Then you have 4x minus 7 is equal to 9. 3 squared is 9. Move your 7 over. 4x equals 16. Divided by 4, x equals 4. Okay, we're not done. Look right here. You must check your answer. Okay, if it's given in log, you must check your answer. So I want everybody to write down the word check. And then I want you to write down log base 3. Then I want you to do a bracket. 4 parenthesis 4 minus 7, close your bracket, equals 2. Now I want you to freeze for a second. Okay? Actually, you know what I'm going to do? I'm going to come, yeah. Go right here. We're on, flip to page 74. These logs are so intertwined. You have to know this to be able to do what we're just doing right here. Look at this. If you have log base A of n, that's log of n divided by log of A. Look right here at example 7. Do you see how this is not log 10? How are you supposed to do it? Because that log button is not going to work anymore, right? So you go log 30 divided by log 4. Everybody write that down. You take the log of that big number divided by the log of the base. Now grab your calculator. Let's make sure you know how to put that in. So everybody go log 30, close it off, divided by log 4, close it off, hit enter, and if we rounded this to 4 digits, then it would be 2.4534. That would be it. Let's do question B just to make sure you're good. So how would you evaluate this? Log 14 divided by log 2. Everybody go log 14, close it off, divided by log 2, close it off. 4 digits would be 3.8074. Who says I understand that? Let me see. Okay, now let's come back over here. We have to apply that in order to check this thing. Okay, putting this in your calculator is kind of tricky, so I want you to watch closely, okay? Grab your calculator and do this with me, okay? Everybody go log. Now, 4 times 4 is 16, right? So I'm going to go 16 minus 7, close it. Then I'm going to go divided by log 3, close it, hit enter. What do I get? I got 2 equals 2. It checks out just fine. My answer is x equals 4. If I don't end up getting a 2, then the answer would be no solution. Okay? Okay, let's do this next one. Everybody in the room tell me, am I stuck? Talk to me. I'm stuck, right? So convert it. So it's x to the second is equal to 64. How do you solve x squared equals 64? What do you do now? Square root it, and you get x equals plus or minus 8. 2 answers. Write down the word check. Write down x equals 8. Got 2 things to check. Everybody go log base 8 of 64 is equal to 2. Grab your calculator and let's put log base 8 of 64 in our calculator. You go log 64, close it off, divided by log 8, close it off. I just got 2 equals 2, x equals 8 is fine. Now we have to check x equals negative 8. So it's log base negative 8 of 64 is equal to 2. Somebody talk to me about that. Is it going to work out? It's not going to work out. So what words do I write right there if I have a solution and it doesn't end up working out? Yeah, invalid solution. So then I'm going to come over here and I'm going to write x equals 8, and that's what I highlighted right there. Okay? Question C. I'm stuck. It's not a log, it's an exponential, but I'm still stuck because there's not like a 2 there. Sorry, I didn't mean to highlight. It's not like there's a 2 there and I could divide by 2, or it's not like there's like a +1 there, and that would make me subtract 1. There's none of that, so I'm stuck. So I convert it. So it's log base e of, pay attention please, the other side, 13 is equal to negative 2x plus 1. Now some people might be saying, why'd she write log base e? Well, what else could I have written? ln. I don't care what you write, doesn't matter to me. So everybody go, negative 2x plus 1 equals ln 13. I'm trying to solve for x. Tell me what to do now. Just tell me quickly, what do I do to solve it for x? No calculator, it didn't ask me to write it as a decimal. What do I do to get my x alone? Move your 1. Everybody write negative 2 equals ln 13 minus 1. I want you to freeze right there. I do not want you to write it like that. Please don't write it like that. Because then my fear is, the next step is you're going to say negative 2x equals ln 12. The negative 1 is outside of the ln. It's not part of the ln. So to prevent that, don't even make that an option, guys. Just write it as negative 1 plus ln 13 instead of ln 13 minus 1. Then I divide by a negative 2, and I get negative 1 plus ln 13 over negative 2. You can leave it just like that. It's fine. Do I have to check this? Do I? What did I say when you have to check it versus when you don't? Who said that? If it's given in log. Was it given in log, Katie? No. So do you have to check it? No. Could you? Yes. On a test or a quiz or a final, should you? Yes. Okay? All right, question D. Let me see how close I am. Okay, if I speed teach, we can do it. Okay, I am stuck. Convert it. So it's y to the negative third equals 1 over 27. You're going to want to watch this closely. Okay? The negative exponent is awkward. That's okay. Make it not awkward. Bring it down to the bottom. Like that. Okay? What to the third gives me 27. What is it? It's a 3 to the third. So y must be 3. 3 to the third is 27. Do I have to check this? Talk to me. Yes, I do. I literally want you to write the word check. And then I want you to write log base 3 of 1 over 27 equals negative 3. Grab your calculator. Make sure you know how to put this in your calculator. So you go log 1 divide 27, close it off, divided by log 3, close it off, hit enter. I got negative 3 equals negative 3. Checks out fine. There's my answer. What do you say to someone when they go, I thought you can't have a negative? I thought you can't have a negative, and now we have a negative. You can't take the log of a negative. Can the value of a log be equal to a negative? Yes. Okay. Question E, stuck. So we have 9 to the negative 1/2 is equal to y. Negative 1/2 is awkward. Make it a positive. So it's 1 over 9 to the 1/2. What is 9 to the 1/2 equal to? Well, how do you rewrite that? Square root of 9. And what's the square root of 9? 3. Your answer is 1/3. You know what a lot of people say? They go, well, why don't you do plus or minus? You know when you do plus or minus? When you do the square root. Was the square root already there? It was already there because it had a 1/2 power. You didn't do that. It was already there. So no plus or minus. You have to check it. Write down the word check. Log base 9 of 1/3 equals negative 1/2. You must check it. Okay? Everybody go log 1 divide 3, close it off, divided by log 9, close it off, enter. You get negative 1/2 equals negative 1/2, and I'm fine. People get confused. Listen what happens. People get a weird answer like y equals 7, and then they'll write log base 9 of 7 equals negative 1/2, and they go negative 1 equals negative 1/2 equals negative 1/2. Yay. Well, I know they didn't put it in. They faked their check. The reason people fake their check is because they don't know how to put it in their calculator. Then they'll get a wrong answer and say, yay, it worked. So you're going to get hit twice if that happens, okay? Yeah.
You don't have to check it with your calculator.
If you can do it in your head, that's great. Yeah, yep, that's great, honey. Okay, here we go with question F. I'm stuck. This is log base 10. So it's 10 to the first equals x minus 1 over x. The second you look at that, you should spit out 2 words that tells me the next step that's the easiest way to solve it. What are the 2 words? Cross multiply. Yep. A fraction equals a fraction. The easiest thing to do is cross multiply. When you cross multiply, you get 10x equals x minus 1. Pull the x over, it becomes a negative. 9x equals negative 1. Divide, x equals negative 1/9. I'm not done. Check. Everybody go log of negative 1/9 minus 1 over negative 1/9 equals 1. Now, you can store negative 1/9 in as a if you want to, and then every time you see a negative 1/9, just hit a. I think it's okay to put it in like this. It's not that bad, except you do have to add, do you have to add parentheses? Yes, you do. Okay, so everybody go log, and then go parenthesis, negative 1 divide 9 minus 1, close your parenthesis, divided by parenthesis, negative 1 divide 9, close it, enter, and I got 1 equals 1. So it worked out fine. There we go. Okay. All right. 12 is easy. 13 is pretty easy, and I'm going to make it. We're going to be good. Okay. Chemists use pH scale to test acidity. I'm sure you guys have done this in your science class, okay? So the equation you have is pH equals negative log of H plus. Seawater has a pH of 8.5. Find the hydrogen ion concentration. So it sounds so much worse than it is. Hydrogen ion concentration is just H plus. Okay? So see this equation right here? The pH is 8.5. So everybody go 8.5 equals negative log of H plus. I'm going to drop the brackets because I think the brackets make you feel confused. And who cares that it's an H plus? You guys, it could just as easily, don't change yours, but it could just as easily be like an X or something, okay? So the H plus isn't scary, it's just a variable, okay? All right, so this is H plus. I have a question for you. This is a big important question. Are we stuck? We are not stuck. You cannot convert right now because the log is not alone. Why is it not alone? The negative. Good. So now we have the log of H plus equals negative 8.5. Am I stuck now? Yes or no, guys? Yes. So this is log base 10. So 10 to the negative 8.5 is equal to H plus, and we're going to leave it right there. Okay, question 13. The normal healing of wounds can be modeled by this equation, where A sub 0 is the original size of the wound, and A is the area of the wound after n days. So guys, you have this boo-boo, and it's getting better, 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 better. Smaller, smaller, okay? So it originally is 100 square millimeters, okay? So everybody write A sub n equals 100 E to the negative 0.35 n, okay? How many days until the wound will be half of its original size? Everybody write n equals and A sub n equals. Read the words. A sub n stands for the number of days. A sub n is the area of the wound. How many days will it be half of its original size? Well, guys, you're looking for n. So I know my n is going to stay an n. So I have to put something for area. Somebody tell me what to put over there. 50. Why 50, Kyla? Half of what it was, right? Half of the original size. If it started at 100, half of it's gone, that's going to be a 50. Who says gotcha? Tell me, guys. Okay. Are we stuck? Is the base and the exponent by itself? Talk to me. No. What's there? 100. How do you get rid of it? Divide. So now I have E to the negative 0.35n is 50 divided by 100, which is 0.5. Am I stuck now? Talk to me, guys. You got to know. If you don't know if we're stuck, it's over. You got a base and you got an exponent and there's nothing else over there. So we're stuck. So we go log base E, that's ln, of 0.5 is equal to negative 0.35n. I just converted it. Log base e of 0.5, that's ln 0.5, is negative 0.35n. To solve, you divide, so it's ln 0.5 divided by negative 0.35. Grab your calculator. Go ln 0.5, close it off, divided by negative 0.35, hit enter, and you get n equals, we're going to say 2 digits in the directions. So it's going to be 1.98. N stands for days. You know you have to have a label, and we're done. Who says gotcha? Let's see. Okay, let's finish this. How long before the wound is 10% of its original size? So how long, that means how many days. So they're looking for N. Somebody tell me what to put on this side over here. It is 10. 10% of 100 is 10. Am I stuck? Talk to me. No, what do I do? Divide by 100. So I have e to the negative 0.35n is 10 divided by 100. That is 0.1. You're making me nervous with this question. Are we stuck? Okay, look right here. 2 to the x minus 1 equals 4. That is not stuck. Add 1, 2 to the x equals 5. Now we're stuck. Look at this. 3 times 2 to the x equals 9. Not stuck because of the 3. Divide by 3, 2 to the x equals 3. If you have e to the 4x minus 1 equals 7, you're stuck. Here's why you're stuck. Look, this is important. You've got a base, you've got an exponent, there's nothing else over there. Stuck. Freeze for 2 seconds. Am I stuck right here? Talk to me. You better tell me or I'm not going to let you go. Yes, you're stuck. Write it with me. Don't pack up. ln 0.1 is negative 0.35n. N equals ln 0.1 divided by negative 0.31. Everybody go ln 0.1, parenthesis, divided by negative 0.35. Hit enter. We're going to go 2 digits, and it is 6.58, and that is days. Okay? All right. That's it.